Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. So this is second part of paper 1-2 from May-June 9701. Let's start. Question number 14. Which statement explains why iodine is less volatile than chlorine? Chlorine is more electronegative than iodine and so has more repulsion between its molecule. So the volatility does not depend on the repulsion between its molecules. So this is chlorine is incorrect. The greater number of electrons in the iodine leads to larger temporary dipole induced dipole forces. Yes, this is correct because down the group number of shells are going to increase and number of electrons are also increased, so that's why more dominant temporary dipole induced dipole forces are present in iodine, so it is less volatile than the chlorine. So this option is correct. The iodine bond energy is smaller than the chlorine bond energy. So this is incorrect because chlorine bond energy is bond length is shorter than the iodine. So bond energy, so this is also incorrect. The iodine molecules have stronger permanent dipole forces. No, it is incorrect because iodine has no dipoles, so it does not have stronger permanent dipole forces. So B is correct. Ammonium carbonate is a crystalline solid. On gentle warming, a reaction occurs forming ammonia as one of the product. So this is the reaction when decomposed to form ammonia plus water plus carbon dioxide. How are the carbonate ions behaving during this reaction? Ammonium ion and carbonate. So because ammonia is formed, so this is the proton donor when ammonia is formed, and carbonate, it is proton acceptor because NH3 and HCO3 form. So carbonate ion is proton acceptor, so that's why it acts as a Bronsted-Lowry base, because proton acceptor is a base and proton donor act as a Bronsted-Lowry acid. So this option is correct, and this is Bronsted acid जो है वो that is proton donor. So this is not proton donor. Carbonate ions are proton acceptor, so that's why it is Lowry Bronsted base. One molecule of an oxide of element Z reacts with 6 molecules of water to produce an acidic compounds. One molecule of an oxide of element Z reacts with 6 molecules of water. 6 molecules of water plus Z reacts with oxide of Z reacts with to produce. So non-metallic oxides when dissolve in water to form acidic compounds, so it is non-metal. Aluminum oxide form amphoteric oxide, so this is not form acidic solution. And phosphorus is the non-metal which form acidic oxide, so this is incorrect. This is correct. This must be correct because this is non-metal. Silicon is non-metal, but it forms silicon dioxide is insoluble in water, so that's why it is incorrect. And sulfur dioxide, yes, sulfur dioxide form acidic solution, but sulfur dioxide react with water to form 1 mole of water. Over here 6 moles of water to form H2SO3. So this is also incorrect. So P is correct because P4O10 when react with 6 moles of water to form 4 moles of phosphoric acid, H3PO4. So this is correct. Which property shows an increase from magnesium to barium? The first ionization energy of the element. Which property shows an increase from magnesium to barium? This is magnesium and barium are present in group 2. So this is beryllium, magnesium, calcium, strontium and barium. So this is group 2 element. And increases, which property increases downward? The first ionization energy of the elements, first ionization energy of element decreases downward down the group 2. So this is incorrect. The oxidation power of the metals, no, stronger the metal, stronger the reducing agent. So stronger metal act as a stronger reducing agent. So it is also downward reducing power is going to increase, not oxidizing power. Reducing power is increased, not oxide. So this is also incorrect. Solubility of the hydroxides. Yes, solubility of hydroxide is increased downward because magnesium hydroxide is insoluble, calcium hydroxide is sparingly soluble, strontium hydroxide is soluble, and barium hydroxide is also soluble. So this is correct. The solubility of the sulfates decreases downward because downward barium sulfate is insoluble, magnesium sulfate is soluble, but calcium sulfate is insoluble, and strontium sulfate also. So solubility of sulfate decreases downward. Solubility of hydroxides increases downward. So this is correct. A test tube of HBr and a separate test tube of HI are heated to the same temperature. Which combination of the observation is possible? Okay, a brown vapor appears, test tube HBr and separate test tube are heated to same temperature. HBr, a brown vapor appears, no change. So this is incorrect. This is also incorrect because hydrogen bromide cannot decompose to the same temperature or heated to the same temperature. A purple vapors appears, so this is also incorrect. No change. No change, a brown vapor appears. This is correct, but brown vapors does not appear. Purple vapors should be appeared. So this is incorrect. So C is also incorrect. No change. Yes, at the same temperature, HBr, HI decompose to form H2 and I2. So in the form of gas, the iodine gaseous form, it is purple vapor. So at the same temperature, only hydrogen iodide decompose to hydrogen ion, but HBr does not, because HBr is stable than HI. So this is correct. Most modern cars are fitted with catalytic converters in the exhaust systems, which three gases are removed by a catalytic converter. Yes, carbon monoxide is removed to form carbon dioxide. Hydrocarbons are also removed, and nitrogen oxide is also removed, because carbon monoxide is oxidized to carbon dioxide. CXHY also carbon dioxide and water, while nitrogen oxide is also decomposed to form nitrogen. This is the typical reaction of catalytic converter, in which carbon monoxide, nitrogen monoxide is converted into more harmful to less harmful gases. So this option is correct. Carbon monoxide, carbon dioxide incorrect, nitrogen oxide is correct. So this is also incorrect. Carbon monoxide, nitrogen oxide, sulfur dioxide incorrect, correct. So this is also incorrect. Hydrocarbons, nitrogen oxides and sulfur dioxide. So A option is correct. Compound X is shown. Compound X is shown. X is treated separately with sodium hydroxide aqueous and lithium aluminium tetrahydride to give Y and Z. Sodium hydroxide. So aqueous sodium hydroxide react to form CO2 Na, and lithium hydride addition of hydrogen. So this is also correct. It forms when lithium hydride carboxylic acid changes into CH2OH, and this is OH, because in this bond, double bond cannot break down, so that's why this structure is formed in the presence of lithium aluminum hydride. So which option is correct? What are X, Y and Z? So this is correct, and this is also correct. A option is correct. CO2H H. So this double bond cannot break in the presence of lithium aluminum hydride. CONO, this is correct, but this is incorrect. CH2OH, this is correct, but this is incorrect. OH do not react with sodium hydroxide aqueous. So this is incorrect, this is also incorrect. So A option is correct. The table shows the molecular formula of three molecules P, Q and R. None of the molecules are cyclic. PCH4O, none of the molecule is cyclic. Yes, CH4OH. So this is CH4O. This is methanol. So this is not cyclic. CH2O2. CH2O2. This is methanoic acid. Oh, H and CH2O. This is methanol. Okay, which molecule shows a strong absorption between 1610 and 1750 in their infrared spectrum? Strong absorption between 1610 and from the data booklet QCH4 shows absorption between 1610. C double bond O, C double bond O, present shock peak 1610 between 1610 and 1750. So this present in carboxylic acid, methanoic acid and methanol. So C double bond O, OH broad peak, which is present 3000 in between 3000 to 3200. So there is round about 25, I think so, to 3000, that is OH peak, so which is absent. So 1610 and 1750, Q and R. So C option is correct. Which row correctly shows the type of mechanism of each of the two reactions? C2H4 5Br plus KCN, CH3COO. C2H5Br to form C2H5CN. So this is nucleophilic substitution. CH3, C double bond O, CH3. So and HCN. So this bond CN to form so this is CH3 and this H positive to form COOH CN, and this is nucleophilic addition. This is nucleophilic addition and this is nucleophilic substitution. This is substitution and CN is nucleophile. So nucleophilic substitution and nucleophilic addition. So D option is correct. It is not electrophilic addition, electrophilic substitution, nucleophilic addition is correct. This is incorrect. Nucleophilic substitution is correct. Electrophilic addition is incorrect. So D option is correct. Ester X is shown. CH3CO2 CH27 CH3. If ester X is hydrolyzed using aqueous sodium hydroxide, what is the molecular formula of one of the product? So this is carboxylic acid, CH3CO2, CO2 CH3CO2 Na, because sodium hydroxide aqueous alkaline hydrolysis gives sodium salt and plus OH CH2 7CH3. So one is alcohol, another is sodium salt due to the alkaline hydrolysis. So CH3CO2, the molecular formula of this compound is C2H3O2Na. So C2H4 incorrect, C2H3O2Na. This is correct option. So this cannot be, this is also cannot be. Which reagent could be used to distinguish between propane 1,2-diol and ethane 1,2-diol? Alkaline 1,2-diol and ethane. Propane 1,2-diol. Propane CH2 CH3. This is propane 1,2-diol and ethane 1,2-diol. CH2 CH2. This is ethane 1,2-diol and this is propane 1,2-diol. Which reagent could be distinguished between propane 1,2? Alkaline aqueous iodine. Yes, this can react with alkaline iodine to form yellow precipitate of CH triiodomethane. So this is CH2 not CH3 with OH, so that's why no change with ethane 1,2-diol. So this is correct. Aqueous acidified dichromate react with both compounds, so similar test, so it is incorrect. Ethanol and a few drops of concentrated acid. Ethanol and few drops of concentrated sulfuric acid is also incorrect. So same reaction with both compound, and sodium metal also shows same compound with like ONA CH2 ONA CH2 ONA, the same compound with this same observation. Hydrogen gas is formed, effervescence of hydrogen. This is also incorrect. Which substance forms propanoic acid as one of the product when it reacts with hot concentrated acidified potassium manganate? Form propanoic acid as one of the product when it reacts with hot concentrated acidified potassium manganate. But1ene CH3 CH2 CH double bond CH2 propanoic acid. So when it reacts with acidified MnO4 H positive, so double bond is going to break over here. So one is CH3 CH2 CO2H plus carbon dioxide and water. CH2 is converted into carbon dioxide and water. So but1ene, this is correct. This is correct option. And but2ene CH3 CH2 CH3 but2ene CH double bond CH3. So double bond is going to break to form two molecules of ethanoic acid, CH3CO2H. 2-methyl propene. 2-methyl, this is incorrect. 2-methyl propene CH3 CH3. This is CH3 propene. 2-methyl propene. C double bond CH2. So so this cannot be propanoic acid because H is absent with this carbon. So this is also incorrect. 2-methyl but 1-ene. This is 1A. This is B option, and this is C. And 2-methyl but 1-ene. 2-methyl CH3 but 1-ene. So CH3. So this is methane. This is propanone. 1, 2, 3, 4. Propanone is formed. CH3, CH2. So this is also incorrect. So the structure of damascenone is shown. Damascenone. This is damascenone, including damascenone. How many stereoisomers exist with this structural formula? With this structure in cyclic, there is double bond here, double bond here. So stereoisomer is not possible in cyclic structure. So the only stereoisomer cis trans is present with this double bond. So CH, and this is CH3, and this is two different groups are attached with this carbon. Double bonded carbon should attached with two different groups on. So this double bonded carbon has two different groups, and this double bonded also has two different groups. So this is cis damascenone and trans damascenone. So two isomers are formed, cis trans. How many isomeric esters have the molecular formula C4H8O2? So let's try CH3, C double bond O, CH2, CH3. This is one isomer. This is second isomer, CH2, CH3, and this is another isomer, ester, CH2, CH2, CH3. And this is another type of isomer, CH2, CH3. This is branched isomer. So this is ethyl ethanoate, and this is ethyl propanoate, and this is propyl methanoate, or this is branch isomer. C2. This is 2-methyl isopropyl methanoate. This should be isopropyl methanoate. This is propyl methanoate, and this is ethyl propanoate, or this is 1,2-ethyl ethanoate. So 4 isomers can be produced from C4H8O2. This is correct. Incorrect. Ethene reacts with aqueous bromine to give two products, CH2Br, and CH2Br, CH2OH. Okay, both products are obtained in this reaction by nucleophilic substitution. So CH2Br, this is Br and Br. This is nucleophilic electrophilic addition, CH2Br, CH2OH. So both products are obtained in this reaction by nucleophilic substitution. No, this is incorrect. Both products are obtained in this reaction by nucleophilic addition. No. Both products can be hydrolyzed to form the same organic form. Both products can be hydrolyzed. Yes, both compounds can be hydrolyzed to form the same organic product. Hydrolyzed to form the same organic product. So this is correct. Both products can form hydrogen bonds with water. No. Hydrogen bonds, because hydrogen bonds are formed when CH2Br, this is one molecule form hydrogen bond, but 1,2-dibromoethane cannot form hydrogen bond. So this is also incorrect. PVC is used as a packaging material. What holds the different polymer strands together in a piece of solid PVC? So this is the structure of PVC. Covalent bonds, which holds different polymer strands together in a piece of solid PVC. So not covalent bonds, hydrogen bonds, no hydrogen bonds, ionic bonds are also not possible. So van der Waals forces are possible. Van der Waals forces are responsible to hold the different molecule strand together in a piece of solid PVC. The diagram shows the structure of buta-1,3-diene. The addition reaction between buta-1,3-diene, two molecules of hydrogen bromide, can produce three structurally isomeric products. The addition of between buta-1,3-diene and two molecules of hydrogen bromide, HBr, can produce three structurally isomeric products. How many of these products have at least one chiral center? Addition of reaction between and two molecules of HBr. Two molecules of HBr to form CH2, CHBr, CH2, CH2Br. So this is another CH2Br, CH2, CH2, CH2Br. And there is another possibility, CH3, CHBr, and CHBr and CH3. So there is no chiral carbon. BrCH, there is no chiral carbon. CH3, CH2, CH2Br, HBr, CH3, one only. So not possible, no chiral. CH2, 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 CH2Br, and this is 2 molecules of HBr. How many of these products have at least one chiral center? So this is chiral center and this is chiral center. How many of these products? This is also chiral. 2 of the products have chiral centers. Chiral center is the carbon atom which is surrounded by 4 different groups. So this is HBrCH3 and CHBrCH3, and in this compound this is CH, this is chiral surrounded by this different compounds. H is different, Br is different, and CH3 is different. So 2 molecules which have chiral center. Scientists are trying to synthesize a new elements with proton number 119. The element is predicted to be group 1 element of period 8, group 1 element in period 8 of the periodic table. Which predictions are likely to be correct about this element? The outermost occupied orbital of one atom of this element will be an s orbital. Yes, this is correct because this is present in group 1, and group 1 last outermost orbital is s orbital. Atomic radius will be the largest of the 7 elements in the group 1. Yes, this is also correct because downward atomic radius is going to increase due to increasing the number of shells. It will have a greater first ionization energy than element 118. No, it is lowest ionization because down the group ionization energy is decreased because increasing the number of shells and number of electrons. So this is incorrect. So if 1 and 2 are correct, so the option will be B. 32. Which reactions would have the reaction profile? Sodium hydroxide HCl, this is exothermic reaction. This is neutralization reaction. Neutralization is an exothermic reaction. Calcium carbonate is decomposition, so it is endothermic. Decomposition is also endothermic reaction. Magnesium oxide is also decomposed to form magnesium and oxygen molecule, so it is also endothermic reaction. Because it is decomposition, decomposition is endothermic reaction, and neutralization is exothermic reaction. And this energy profile diagram for endothermic reaction, because this is reactant, products, and activation energy is more energy is absorbed than released. This is activation energy. So if 2 and 3 are correct, the option is C. No other combination of state. Question number 33. Which factors can lead to an increase in the rate of reaction? A lower activation energy. Yes, when increase it lowers the activation energy, increase the rate of reaction. An increase in temperature, yes, increases the rate of reaction. Increase in concentration of the reactant, this is also correct. So if three options are correct, three statements are correct, the option will be A. 34. Sodium and fluorine are both reactive elements. Two atoms are described, atomic number 9 and 11, 19 and 23. Nucleon number is 19 and 23. Which statement about these two atoms and ions they can form are correct? One sodium atom has two more protons. One sodium atom has two more protons than one fluoride ion. Yes, it is correct. One sodium atom has two more neutrons. One sodium atom has two more neutrons. So in this case, sodium has 12 neutrons and this has 10 neutrons. So two more neutrons than one fluorine atom. This is also correct. One sodium ion has the same number of electrons as the fluoride ion. Yes, after losing, sodium has 10 electrons, and after gaining nitrogen, fluorine has 10 electrons. So fluoride ion and sodium positive has 10 electron each. This is 10 electrons. So this is also correct. This is option A. In the atmosphere, which transformations can involve sulfur dioxide as either a reagent or a catalyst? Nitrogen dioxide to nitrogen monoxide, reagent or a catalyst, sulfur dioxide. Nitrogen dioxide, sulfur dioxide. In the atmosphere, which transformations can involve sulfur NO3 SO3 plus NO, and can involve sulfur dioxide as either a reagent or a catalyst. SO3 plus water to form H2SO3, NO2 to NO, reagent, sulfur dioxide as a reagent, as either a reagent or a catalyst. Yes, this is correct. NO to NO2, NO plus SO2, SO3 and 2, no, this is incorrect and this is also incorrect. So this is incorrect. The bond P of the HBr and HBr molecule is dash than that of the HI molecule. Which pairs of words correctly completes the above sentence? The bond energy of the HBr molecule is greater than that of HI. This is correct. The bond length of HBr is less than the HI. Yes, this is also correct. Polarity, bond polarity of HBr molecule is greater than that of HI. Yes, because electronegativity decreases downward, so bromine is more electronegative than iodine, so that's why bond polarity is greater of HBr molecule is greater than that of HI. So this is also correct. A option is correct. Compound X has the structure shown. Which statements about compound X are correct? X will decolorize cold acidified KMnO4. Aqueous, yes. X will decolorize. No, this is not correct because this is CH3, CH3, C. This is tertiary alcohol, cannot react with, and this is ketone, so will decolorize cold. This is incorrect. X gives an orange precipitate with 2ND, 2,4-D and pH reagent. Yes, this is correct because ketone gives positive test with the 2,4-D and pH reagent. X does not react with toluene. Yes, it is also correct because ketone does not react with the toluene reagent. It react with aldehyde. So if 2 and 3 are correct, the option is C. Propanol reacts with hydrogen cyanide. Which absorptions are present in the infrared spectrum? Which absorption? Hydrogen cyanide, propanol, CH3, CH2, C double bond, OH. Hydrogen cyanide. Which option is correct? Which absorptions are present in the infrared spectrum of the product? A weak absorption in the range 2200 to 2250. A strong absorption in the range 3200. Yes, CH3, CH2, C double bond O and HCN, which is positive, and CN is negative ion cyanide. So this is H propanol to form CH3, CH2, C double bond O, H, COH. This is, and this is structure. And CN. So this is correct. OH peak is absent, so weak absorption. This is correct. 3200 C36 strongest absorption. Weak absorption in 2050. So strong absorption in the range 32. So OH is present. So strong absorption in the range of 3200 to 36. This is correct. A strong absorption in the range 1040 to 1300. So this is CN. Bond absorption, strong absorption. This is also correct. So A option is correct. Which alcohol cannot be dehydrated to form alkene? Cannot be dehydrated because this is methanol. Methanol cannot be dehydrated to form alkene. So this is one carbon is there, so incorrect. So this is CH3, CH3, CH3OH. This can be dehydrated to form alkenes, yes. OH and can be dehydrated H of this carbon to form alkene. CH3 C H3 C double bond CH2. This is also dehydrated to form alkene, so cannot dehydrate it. So this option is correct. Only this option is correct. This can be dehydrated like this. CHOH and CH3. CHH. This can be to form CH3 CH double bond CH2. This is also dehydrated to form alkene. So if one option is correct, so D, if one statement is correct, D is formed. A reaction mechanism is shown. Reaction mechanism is shown. Which statements about these reactions are correct? Heterolytic bond fission occurs. Yes, heterolytic bond fission occurs. This is correct. It is substitution reaction. OH is substituted and bromine is removed. So this is substitution reaction. This is correct. OH negative behaves as an electrophile. No, this is nucleophile. So this is incorrect. So if two options are 1 and 2 are correct, then option is B. So this is all about. If you like this video, please subscribe, like and share this video.